All right, so here we are. We're going to do some operations with radicals, specifically radical terms, but um, it's really straightforward and simple. We just have to kind of think of a radical throughout all of these processes as its own variable or pronumeral. So let's just dig right in. So addition, subtraction. I guess I'm not even going to write that because I already have it written above, huh? So if I did like the square root of 3 plus 2 square roots of 3 plus 8, if we imagine the radical, instead of thinking of it as a radical, think of it as an exponent, or no, sorry, a variable. Think of this, instead of writing it like that, what if I wrote x plus 2x plus 8? Well, that's no big deal. I would just end up saying that this is 3x plus 8. Well, that's all that happens with radicals. All we can do is we gather like radicals, because the square root of 3 and the square root of 3 are the same thing. We can gather that together, and this would actually turn out to be 3 square roots of 3 plus 8. Now, a lot of times when I write something after a radical, I put that little close box on my radical just to make sure that everyone remembers that we're stopping there. That's as much as we're taking the square root of. Okay? Same thing happens with subtraction. We can do this infinitely, but if I had 3 square roots of 5 plus 2 square roots of 2 plus 5 square roots of 5 minus 3 square roots of 2, well, again, here, we can only combine similar radicals. That's all we can do, is we can gather radicals together. So in this case, I can add together my 2 square roots of 5's, which is 8 square roots of 5's. Similarly, I can combine my square roots of 2 terms, which would give me negative square root of 2. And the reason why it's negative, positive 2 square roots of 2. Take away 3 square roots of 2, negative 1 square roots of 2, or negative square root of 2. I think that's doable, super manageable. Now, we've already seen how we can multiply radicals, but what we want to be able to do is to take and multiply something like 1 plus the square root of 2 times 3 minus the square root of 2. Now for this, what does that look like? I heard you there. Yeah, that's right. It looks like a binomial. We're multiplying binomials. This is a quadratic. This is a factored quadratic. That's exactly what we're going to do with this. We're going to treat it just like we would any other um, binomial. We're multiplying two binomials, products of binomials. We're just going to follow through again. Now, again, I like the FOIL method. That's what I'm going to do. So I'll do 1 times 3, which is 3, and then 1 times negative square root of 2, which is minus the square root of 2, and then the square root of 2 times 3, which is plus 3 square roots of 2, and then the square root of 2 times negative square roots of 2, which would give me minus 2. Square root of 2 times the square root of 2 is 2. One of them's negative, so we have that. Gathering like terms, we would end up with 1 plus the square root of 2. That is super helpful. That is something that we really, really like. Now, every single one of the rules that we've seen before works. If I take and I go, let's do 3 plus the square root of 7, and I square it, that's a perfect squares expansion. That's going to be a squared plus 2ab plus b squared. That's what's going to happen every single time. So if I did that, I would end up with 3 squared squared plus 2 times 3 times the square root of 7 plus the square root of 7 squared. Simplifying that out, I would get 9 plus 6 square roots of 7 plus, well, if I square a square root, I'm multiplying them together. I'm multiplying it by itself. I just get rid of the square root symbol. So this is just going to turn into 7. Further finishing this, I would end up with 6 plus 6 square roots of 7. C'est la vie, we've done it. Congratulations. What's interesting is what happens when I have this situation. 5 minus square roots of 3 times 5 plus square roots of 3. What is that situation called? You're going to have to speak louder. I can't hear you. Right, I'm not going to be able to hear you at all. Sorry. This is difference of two squares. Difference of two squares is something that we love because it becomes very, very easy. Difference of two squares says when we have this situation, we square the first term and we subtract the square of the second term. So it's going to be 25 take away, well, the square root of 3 squared. What's the square root of 3 squared? I know we've already discussed I can't hear you, so it's going to be 3. So it turns into 25, take away 3, or 22. When we have the difference of two squares with radical expressions, we love it. Because now, notice, when I did it this time, I ended up with the square root still left over. Here, I still have the square root left over. Difference of two squares. Goodbye, square roots. That's going to come in handy in a little while. Hope this is helpful. I know this is enough information to get you going. And if you try the problems, you'll be awesome. All right, have a good one. And that didn't actually end the video. I'm going to stop.